Okay, so I'm going to go through some of the problems on this example, this exam one practice problems sheet. There were a few questions sent to me in my email. I'm going to go ahead and answer those. So number 4, this is a verify the or establish the following identities problem. So let's go for it. We have 1 minus tangent of t over sine t, and then that is equal to cosecant t minus secant of t. Okay, so I look at this problem and I think, all right, I've got sines, I've got tangents, I've got cosecants, and I've got secants. I don't like that. I'm going to try to get everything in terms of sine and cosine. So on this side, I'm going to write this as 1 minus sine t over cosine t over sine t. And then I'm going to keep going just to get a common denominator on the top. Like I'm going to multiply this by cosine t over cosine t so that I can write that as cosine t minus sine t over cosine t. And this is all over sine t. Okay. If I move over here, I have 1 over sine t minus 1 over cosine t. I'm going to go for combining those right now. So getting a common denominator, oh, there it is, getting a common denominator, that would be sine t times cosine t. So on this side, I need a sine t over sine t. On this side, I need a cosine t over cosine t. So I have cosine t minus sine t, or looking at 1 times cosine t minus 1 times sine t. Okay, so I actually am done. I'm going to go back over on, I should make these a different color. Let's see, let me split these. So I'm going to go back over here now, and I'm going to keep change flip. So cosine t minus sine t over cosine t times, this is sine t over 1 times 1 over sine t. And then there we have it. Okay, so I have made them look the same now, and so that is good enough, and I am done. That is tricky. There's a lot going on there, but the getting things in terms of sine and cosine, and then working both sides to sort of help yourself, that is wise. I'm going to work number 5 as well. So number 5, we have sine x over cosine x over here. On this side, we have 2 sine x cosine x, that's a double angle identity for sine, over, what should we use? 1 plus cosine squared x minus sine squared x. Okay. Cosine squared x. Okay, I want to cancel that cosine out of the top. I make this 1 minus cosine squared x. Just using a different version of the double angle identity. Ooh, let's see what's happening there. So 1 plus cosine squared x. Okay, so 1, oh, put your top on there. We have 1 plus cosine squared x on the bottom minus 1 plus cosine squared x again. Yeah, there it is. Okay. So on the top, I have 2 sine x cosine x still. All right, and then on the bottom, those ones are going to cancel. And I am going to combine those 2 cosine squareds. So the 2's cancel. This is sine x times cosine x over cosine x times cosine x, and then those go away. So we have sine over cosine, which is what we wanted. Okay, so those are two identities. They're kind of tricky, but they mostly involve a lot of definitions of trig functions or identities and then doing some algebra. All right, so I had someone ask about 8 through 11 here on this. These are basically just some identity is sitting here and we're supposed to figure out which one it is. So on number 8, the sine of 15, you would evaluate this using like the sine of 30 over 2, the half angle identity. On this one, this is 2 sine theta cosine theta, that's the pattern. So this is the same thing as sine of 2 times 22.5 degrees, which is sine of 45, which is root 2 over 2. This one is actually a double angle identity for cosine. So the double angle identity is that cosine of 2 theta, one of the forms is that this is 1 minus sine squared theta. So this is equivalent to cosine of 2 times pi over 12. That's pi over 6. And the cosine of pi over 6 is root 3 over 2. This one is also a double angle identity for cosine. This version is cosine of 2 theta is cosine squared theta minus sine squared theta. So this is equivalent to the cosine of 2 times 105 degrees. That's the cosine of 210. That's cosine of 210, which is 210 is here, so negative root 3 over 2. This one, number 10, it goes sine, cosine, cosine, sine. So I know that this is, and it has a negative. So this is the difference formula for sine. So this is going to be the sine of 7 pi over 12 minus pi over 12. That is the sine of 6 pi over 12, which is the sine of pi over 2, which is 1. On number 11, use the sum formula for tangent to expand. So you're going to have tan alpha plus tan beta over 1 minus tan alpha, tan beta. The tangent to pi over 3 using my left-hand rule is root 3. Pi over 4 is 1, and then 1 minus root 3 times 1. This is another half angle here, the sine of 45 over 2. And then keep going. Okay, and then lastly, someone asked about the triangle problem. So we're going to go through this. The cosine of theta is negative 3/5, and theta is in quadrant 2. So we are going to put theta in quadrant 2. And what we're going to do on these is basically just find our, figure out what formula we're supposed to be using, and then use it, and then look at our picture. So cosine of theta is negative 3/5. So those are these sides. And then this third side is 4. Pythagorean theorem would give that to you, or knowing that this is the Pythagorean triple. So 9 plus b squared is 25. So b squared is 16. So b is plus or minus 4. All right. So what formula? Then use your picture or the unit circle. So sine of 2 theta formula is double angle identity. So we are going to write down 2 sine theta, cosine theta, and then we're going to use our picture. What is the sine of theta? It is 4/5. What is cosine of theta? -3/5. And then multiply straight across, that's -24/25. Tangent of 2 theta, you're going to have this formula, but it's 2 tan theta over 1 minus tangent squared theta. This is double for tangent. All right, so the tangent of theta is opposite over adjacent, so -4/3 over 1 minus -4/3 squared. So that is 2 times 4 is 8, -8 over 3 over 1 minus 16 over, 16 over 9. This is actually 9 over 9, so I have -8/3 over 9 minus 16 is -7 over 9. Oof. And then the keep change flip. This is a 3, so this is 24 over 7. Lots of arithmetic there. Common denominator, so we can actually subtract, get a fraction in the denominator, and then flip it and multiply. All right, sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta. This is the half angle identity. So the thing is, how do we know what quadrant to choose? So theta is in quadrant 2, so between 90 and 180. And that means that theta over 2 is between 45 and 90. So it's in here, and the sign value there is positive. So we are going to choose the positive square root here. Cosine of our thing was -3/5. Okay. So we have the square root of 1 plus 3/5 over 2. If you were to continue to simplify, that's 5, that's 8/5 over 2, which is 2 over 1. 8 divided by 2 is 4, so this is the square root of 4/5. Multiply by 1/2, multiply by 1/2. Yeah. Okay. On number 16, you are going to use the difference formula for cosine. So it goes, let me use a different color. It goes cosine, cosine, sine, sine, opposite sign in the middle, alpha, beta, alpha, beta. So on this one, we're going to use our unit circle and our picture. So the cosine of 45 degrees is root 2 over 2. The cosine of our angle given to us in this picture is -3/5. Okay, then the sine of 45 degrees is root 2 over 2. And the sine of theta is 4/5. And then you're going to multiply straight across. So -3 root 2 over 10 plus 4 root 2 over 10. That is just 1 root 2 over 10. -3 plus 4. All right. Tangent squared theta is just going to be the tangent of theta squared. The tangent of theta is opposite over adjacent, so we have -4/3 squared. That is 16/9. Okay, so triangle problems, use your identities, and then use your picture or your unit circle, or both. Yeah. Okay, if you guys have any more questions, send me an email. I'll do another video with more. later. Thank you.